Hello everyone, welcome to HCAA Storage version 5 training courses. In the previous session, I introduced to you the evolution of storage architecture. In this session, we will focus on the development of storage media and explore how the various storage media have evolved into their current forms. Before formally introducing the details, let's first recall and summarize together. Which types of storage media are commonly used in our various scenarios? The storage media we mainly use in our production environments at present are disks and memory. Disks can be broadly classified into two types based on their working principles and mechanical structures. Hard disk drive (HDD) and solid state drive (SSD). Besides the disks primarily used for carrying out production services, there are other storage media involved in various application scenarios. For example, in the scenarios of backup and archiving, media such as CDs and tape libraries may be used. On a personal level, there is a wider variety of storage media that may be used, including USB flash drives, SD cards, memory sticks, and DVDs. In this session, we will primarily focus on discussing the development history of disks, which are most commonly used in enterprises. The birth of HDD was earlier than SSD, with the history traceable back to the 1950s. IBM launched the world's first disk, known as the 350 RAMAC, Random Access Method of Accounting and Control. The size of this disk was so large that the device took up an entire room. Despite this, it is widely used in early computer systems. With advancements in technology, the size and the weight of disks have been continuously decreasing. IBM's products gradually downsized from 14 inches to 8 inches, marking the official entry of HDDs into the civilian market. In the mid to late 20th century, the storage density of hard disk platters was growing at an astonishing rate, doubling 1 to 2 times every year. During this period, 3.5-inch disks began to become mainstream because their size and weight were further reduced, enabling widespread use in personal computers. This 3.5-inch size and the 2.5-inch standard that appeared at the beginning of the 21st century has been adopted up to now, becoming the most commonly used disk size standards in current data storage solutions. Notwithstanding the passage of time, HDDs have not ceased their technological advancements. The size of disks is being further compressed and their capacity is constantly increasing, with HDDs in production environments often having storage spaces of several terabytes or more. Although SSDs came later than HDDs, there were actually preliminary prototypes of SSDs as early as the 1970s. However, at the end of the 20th century, HDDs gained significant advantages in terms of cost and capacity, leading to SSDs being temporarily marginalized by the market. As I mentioned earlier, HDDs have remained the dominant choice in the personal computer and server markets through continuous technological advancement over a long period of time. However, with the advent of the 21st century, Internet enterprises have imposed even higher demands on storage efficiency. Traditional HDDs, due to their working principles and mechanical structure limitations, can hardly meet the needs of enterprises in terms of read or write speeds, power consumption, and data persistence storage stability. That's why people have to shift their thinking and return their attention to the previously neglected SSDs. It's good to know that during the period when HDD were quite popular in the market, SSDs have been quietly developing all along. Science Bell Labs invented the floating gate transistor technology in 1967, which laid the fundamental principles for SSDs. Related technology companies have consistently focused on this field and have continuously introduced new technologies over the years. The capacity has also grown from 2 megabytes at the beginning to tens of GB at the beginning of the 21st century, when the business model of cloud computing emerged and skyrocketed around 2008. SSDs became the performance backbone of cloud data center storage. We know that HDDs achieved memory through the state of magnetic materials on their disk platters. Unlike HDDs, SSDs achieve persistent state memory through the charge quantity on the transistors in the flash memory chips. So the development history of SSD is actually more of the development history of flash storage media. Let's take a brief look at what versions of flash storage media have gone through since its inception. Single-level cell (SLC) is the original form of flash storage technology, and each storage unit can store only 1 bit of data. SLC has a higher cost and lower storage density than later technologies, but it also has its own advantages, including superior durability and read-write speeds. With 100,000 programmer read cycles or more and extremely fast data access speeds. Therefore, SLC is preferentially used in the military field. The subsequent multi-level cell (MLC) and triple-level cell (TLC) significantly expanded flash memory storage capacity and reduced costs. However, their PE cycles have decreased significantly, which limits their use in high write load scenarios. Subsequent developments in the 3D TLC and QLC technologies focused on the stacking direction and the number of bits per storage units respectively, further enhancing their capacity and PE cycles and offering consumers more cost-effective products. The last mentioned storage class memory, SCM technology, represents a new emerging storage technology with a different approach from the previous ones. It is driving the evolution of future storage solutions towards higher speeds and lower latency. Let's also take a look at this technology. Typically, the memory module or DRAM has high read or write speeds. However, because its capacitor leaks charge over time, DRAM needs to be refreshed regularly to maintain the stored data. In other words, a power outage can result in data loss. To persistent store data, you need to use NAND flash, a non-volatile storage technology, but it is slower to write and erase compared to DRAM. While SCM is a new type of storage technology that falls between the two. It offers speeds approaching DRAM and the non-volatility of NAND flash. The storage field is continuously evolving and deepening in the technical direction of SCM. We can wait and see what heights it can reach in the future. Well, in this session, I have mainly introduced to you the development history of HDDs and SSDs, and discussed various media's design approaches and advantages around the flash storage media. That's all for this session. Thank you for your participation. I will see you in the next session.